GOES started with working with NASA back in the late 60s. In 1966, NASA was going to put up a communication satellite at the geostationary orbit, and Dr. Vern Sumi of the University of Wisconsin-Madison said, well, you need to put a camera on that, a cloud camera, if you will, to watch the evolution of the cloud feature. So that started the whole GOES world, December 6, 1966. So the first camera that we had in 1966 was just a visible channel, which is great if you're looking at clouds, for example, during the day, but the world would then go dark at night. Then we evolved the system to have infrared, or the heat of the radiating surface, and then we evolved to more and more spectral bands or frequencies to look at different layers in the atmosphere. And now we can use that information to better observe the Earth atmosphere system and use that to initialize or start the initial field for numerical model or predictions of what's going to happen. The idea is you can't very well predict what's going to happen in the atmosphere if you don't have a good idea what's happening right now. So the geostationary data is used not just for the imagery that you see on the evening news that the Hurricane Center uses, but also for many quantitative products. The most exciting part to me for GOES is just these rapid images. Today we have this conflict. Do we want to scan a kind of a regional or hemispheric view, or a mesoscale, fine time view? But with GOES we'll be able to do both. So we'll be able to do making full disk images, say every 15 minutes, looking at the continental United States every 5 minutes, but these small areas, 1,000 by 1,000 kilometers, we'll be able to look at, if we look at one spot every 30 seconds, or if there are two regions of interest, we can look at them both for every 1 minute. So then we can see not just what has happened, which is kind of the world we're in now with 15-minute or 30-minute data, but really while it's happening, while the eye is swirling, while the convection is forming. So it's really the temporal resolution. The GOES serves really the whole hemisphere, and so right now we're in a case where if we're going to do rapid scan imaging over the continental United States, then we don't get those images, say, in the southern hemisphere. But now with the GOES we're able to do both of those. We don't have to choose, well, which would be more important, this hurricane or, for example, that dust storm or whatever. We'll be able to monitor them both as we go on.